going to show you a clustering example. And so I have created this artificial data set. And as you can see using make blocks, and as you can see, this data set has got four clusters. So the first cluster has got two samples. The second cluster has got six samples, so six data points. The third cluster has got six samples, and the fourth cluster has got six samples again. And these are the centers for each of the four clusters. So the first cluster, which is these two data points, they have got the center at 1, 2. So x-axis 1 and y-axis 2. So that's the center of this cluster. The second cluster has got center at 3, comma 4, which is 3 along the x-axis, 4 along the y-axis, so somewhere here. And the third cluster has got center at 5, 6, so 5 along the x-axis, 6 along the y-axis, somewhere here. And the fourth cluster has got the center at 7, 8, which is 7 along the x-axis, 8 along the y-axis, which is somewhere here. Now, in this artificial data set, we know that this cluster, this data set has got four clusters. But in a real world data set, you would not know beforehand how many clusters the data set will have, because it's unsupervised learning. And how can you find out that how many clusters should there be in the data set? Because this is an important problem, because let's say you assume that there are three clusters. If you assume there are three clusters, then what the algorithm will do is it will put these two clusters into one single cluster. That's why they've got the same color, then yellow into a different cluster and this into a different cluster. Only if you will ask it to have four clusters, it will actually do what is the truth, which is it has got four clusters and will put all the data points into correct clusters. If let's say you say this data set has got six clusters, so that's an incorrect assumption. Then what the algorithm will do is it will calculate six clusters and it will put the data points into the wrong cluster. For example, this cluster, it will break it down into two different clusters, and these two yellow points will be in a different clusters. These two blue points or purple points will be in the different cluster, although we know that in reality these all should be in the same cluster. So it's very important to make the right guess as to how many clusters the data set should have. In this synthetic data set, we know that this data set should have four clusters. If you guessed correctly, then your data set will have the right clustering, which is the all the data points which are the true cluster will be represented. So now I'm going to show you how can you figure out how many clusters truly your data set has got. So one method is this elbow method. And in this elbow method, you can see that the number of clusters is along the x-axis, and along the y-axis is the value of inertia, which is sum of square distances of the samples to their closest cluster center. And if you plot these two values, then at the value of number of clusters, which will be the true value of the clusters in the data set, you will see an elbow here, right? So that's the first method. And the second method is a Shillett coefficient, which has got a value between -1 and 1, and higher values indicate that it's best for clustering. So as you can see in this data set, the Shillett coefficient has got the highest value at k equals 4, which is this along the x-axis, and hence we know that this data set will have the four clusters. And then you can say that force it to create four clusters and it will be the right clustering. Now let me just slightly change the code and pretend that we have got five clusters instead of six clusters. So I'll say create a fifth cluster with six data points, and for the create a fifth cluster with six data points, and for the fifth cluster I will give it a center of, let's say, 9, 10. When I plot it, you will see that instead of four clusters, our data set will have five clusters instead. So I'm just going to run this again. Okay, so as you can see here, that now my data set, the artificial data set has got five clusters. One is this cluster, second cluster, third cluster, fourth cluster, fifth cluster. Fifth is the one which we added, and the fifth cluster has got center at 9, 10, which is 9 along the x-axis, 10 along the y-axis. Now we know that truly this cluster has got, this data set has got five clusters. And if now I plot the elbow method, you will see that the elbow is at k equals 5, telling you that 5 is the true number of clusters. If you plot the Shillot coefficient as well, then you will see that at k equals 5 now, Shillot coefficient is maximum, almost 1, and hence this data set truly has 5 clusters. So what you can do is you can just give k equals 5 and it will truly plot the number of clusters in the correct way. Okay, so this demonstrates the power of creating artificial or synthetic data sets to test your algorithms. It also shows you the power of elbow method, which is this one. And then it also shows you the power of Shillot coefficient, which is this one, to identify the optimal number of clusters that your data set should have. Okay, thank you very much.